Hi, we will be discussing today's concept, which is hyperconjugation, which is a very important concept in organic chemistry in defining some organic reactions which goes via the formation of carbocation, which is an electron deficient species. So first of all, before starting this, we will be discussing what is carbocation. So like we have studied that for a very stable species it should follow octet rule, okay, in which like the species are 8 electron species or 18 electron species. So these are the most stable species. Like this carbocations, so what is carbocations? When these species are like they do not have sufficient electrons, okay, their octet is not completed, so they do not have sufficient electrons, okay, so these species are termed as carbocations. For example, if we take a simple organic molecule which is CH4, okay, this is methane, okay, so here you can see this one bond contains 2 electrons, okay. So these consist of 1, 2, 3, 4, 5, 6, 7, 8. 8 electron species. This means this particular molecule, this is octet, okay, its octet is complete, okay. But if we define this molecule has structure like this. Okay. So if we count the number of electrons, 1, 2, 3, 4, 5, 6. Here 6 electrons are there. So we can say here 8 electrons, its octet is complete, but here it is 6 electron. So it is deficient, it is electron deficient. So this kind of species we say carbocations. These are we call carbocations, okay. So we represent it by this, where no electrons are there, okay. So these are terms carbocations. So to study these carbocations, now let's correlate why we are studying this. So since organic reactions goes through carbocations formation, so in many reactions these carbocations are formed. So the reactions in which these carbocations will be stable, this reaction will go like faster, okay. So to study like which carbocations will be more stable, we study this effect hyperconjugation, okay. So let's study. Hyperconjugation is called no bond resonance. Okay. So what is meant by no bond resonance? Let's say okay, this is a molecule in which here it has 1, 2, 3, 4, 5, 6. So this particular portion has 6 electrons, which means it is electron deficient. But in this case 1, 2, 3, 4, 5, 6, 7, 8. It is 8 electron species, okay. So this is its octet is complete basically, okay. So that means its orbital, it is empty. It's empty, okay. So what is like hyperconjugation, what it says that if there is one empty orbital and like adjacent to it there is one CH bond because this contains electrons, okay. So when this CH bonds is transferred to this empty orbital, this is what we call hyperconjugation. That means this orbital, its empty orbital is stabilized by its adjacent CH bond, okay, because it is deficient of electrons. So this particular bond helps this orbital to stabilize by providing its own electrons. So what it will form, okay, since this went to this, so CH this bond is broken. So here is H. So this space is empty below. This space is empty. So now this bond it transfers its electron to this empty orbital. Okay, so what it will form here, this H, it will become H plus, since its both electrons went away from this side, and it will form here double bond. So now just look at this, how it will form. 1, 2, 3, 4. If we count for this, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons is this, right? Here 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. So basically, this effect has stabilized the whole molecule. But let's say here, okay, this particular bond stabilized this. Can you see this one? This is also the SCH bond adjacent to this, and also this one also. Okay, so you can say that 3 CH bonds are there which can stabilize this empty orbital, right? So 3, we say these hydrogens, alpha hydrogens. So the hydrogens which stabilize its adjacent empty orbital, these are called alpha hydrogens. So here how much? Now let's say again we do. Now you can say this carbon is adjacent to this. How many hydrogens are connected to this? So this is called alpha carbon. This is called alpha carbon, and hydrogens attached to this alpha carbon are called alpha hydrogens. Okay. Now these 3, okay, so from we make resonating structures, like from this CH we made one resonating structures which I mentioned earlier by this. Okay, also one you can also make with this one, with these hydrogens. And also with this hydrogen. Now you can see how many resonating structures are formed. 1, 2, and 3. So according to the like we study general organic chemistry, in that we learn that the more the number of resonating structures, more will be the stability. Okay, so here 3 resonating structures are formed. Now we will discuss some examples in which the more number of alpha hydrogens will be there, more will be the stability. So like there are many questions in competitive exams, like which carbocations is more stable. So we will discuss now that pretty clear that okay, just remember one thing. One empty orbital will be there, one adjacent carbon will be there, and this empty orbital will take help from its adjacent carbon to fill its empty orbital. Okay, first we will discuss in these two, like which carbocation is more stable. Now first discuss this one. Let's open this structure fully so that we get. Okay, so can you tell like how many alpha hydrogens are there? See, this is empty, or we can say that empty p orbital, right? Because positive charge is there. Now adjacent to this is your alpha carbon, and alpha hydrogens attached to the alpha carbons are called alpha hydrogens. So can you like tell like how many hydrogens are there? 3. How many alpha hydrogens are there? So 3 alpha hydrogens. How many? 3 alpha hydrogens. 1, 2, 3, right? So 3 alpha hydrogens. Let's come to this example. Okay, here this is empty one, empty orbital. Okay, now let's discuss how many alpha hydrogens are there. Before counting alpha hydrogens, just find out alpha carbons. These are adjacent to this carbon. This is alpha carbon, and the hydrogens attached to this. For example, this 1, 2, 3, 3 here. Also, like this carbon is also adjacent to this carbon. So 1, 2, 3, 3 here. So total alpha hydrogens how many? 3, 6. So here total alpha hydrogens 6. So as we discussed, like more the number of alpha hydrogens will be there. So like more will be the resonating structures, and more will be the resonating structures, more stable will be the carbocation. So here 6 alpha hydrogens, here 3 alpha hydrogens. So which carbocation will be more stable? This, more stable. So like we discussed these kinds of questions like come very frequently in JEE and JEE examinations. So we will discuss one more example to tell like which carbocation will be more stable, right? Okay, let's come to this structure. Here this is electron deficient carbon. Okay, so with respect to this carbon we will see like how many alpha hydrogens will be there. So in this carbon, like adjacent to this carbon is this carbon, and hydrogen attached to this carbon will be termed as alpha hydrogens. So just now we have to do it very quickly in our mind. Say electron deficient, adjacent to this carbon is alpha carbon, and attached hydrogens to this alpha carbon are alpha hydrogens. So 3 here, you can see 3. Okay, come to this portion. Now this adjacent carbon to this is this. Okay, number of hydrogens attached to this carbon is 2. Don't go there. These are not alpha hydrogens. No, these are not. These are alpha hydrogens. Okay. Just only one carbon adjacent to the electron deficient carbon. Now come to this. Okay, this is alpha carbon. Okay. Here you see there carbon, carbon, carbon. No hydrogens is attached. So no alpha hydrogens are there. So यहाँ पे 0 alpha hydrogens. Okay. So how many? 1. Okay, it's 3 plus 2, 5. Now come to this quickly. This carbocation. This carbon is adjacent to this electron deficient carbocation. So here 3 here, 3 here, 3 here. 3 plus 3 plus 3, 9 alpha hydrogens. So now you can see 9 alpha hydrogens, 5. So this will be more stable. More stable carbocation. I hope this helps. Like there are many questions related to this. So thank you so much.